In this video, we're going to talk about naming benzene and benzene derivatives. First, let's go over some common benzene vocabulary. In this first example, you can see that a benzene ring is a substituent on the parent chain. Here's the parent chain here in pink. In this case, the parent chain has an alkene, which is why it takes priority over the benzene ring. When the benzene ring is a substituent, it's referred to as a phenyl group. Phenyl can be abbreviated PH or C6H5. So this is the same thing as the molecule on the left here, and so is this one. Another common group that you see is the benzyl group. The benzyl group consists of a benzene ring and a CH2 group. In this particular example, the parent chain is a cyclohexane. Benzyl can be abbreviated BN or C6H5CH2. And this is the benzyl group right here. These are useful to know as they do show up commonly as substituents. They're also used in several common names. For example, benzyl bromide looks like this. First, let's start with nomenclature of disubstituted benzenes. When you have two substituents on a benzene ring, you can name them based on their orientation. For example, if they are directly next to each other or have 1-2 positioning, we would call that ortho. An example of ortho positioning is shown here. These two groups would be considered to be ortho to each other. 1-3 positioning is meta. Here's an example of 1-3 positioning. And then if the groups are across from each other on the benzene ring, they are considered to be para. Here are some examples of ortho, meta, and para positioning. In our first example here, the bromine and the chlorine are right next to each other, so this is considered 1-2 positioning or ortho. We can also just abbreviate as O. The bromine is listed before the chlorine because B comes before C alphabetically. Here we have an example of meta positioning, where there is one CH2 between these groups. We can also refer to this as 1-3 positioning, or M as an abbreviation for meta. In this last one, we have para positioning, where the groups are across from each other. This is also considered to be 1-4 positioning, or can be abbreviated as just P. If you have more than 2 groups on a benzene, you can no longer use ortho, meta, and para. We have to just use numbering. So let's take a look at this example here. None of these groups are particularly significant, so we just want to number to give lowest possible numbers. If we start here, we have a group at 1, 3, and 4. It's better to do 1, 2, 4, because 1, 2, 4 gives us lower numbers than 1, 3, 4. So that means we're going to start at the propyl group. Next, let's name our substituents. We have a propyl group here, a bromo group here, and an ethoxy group here. Our root name is benzene, so if we put this all together, we have 2 bromo, 4 ethoxy, 1 propyl, benzene. In this second example, we have a situation where either way we number it, we're going to have groups at 1, 3, and 5. Since we'll get the lowest possible numbers wherever we start, we're going to have to use alphabetical order to break the tie. Our substituents are bromo, chloro, and ethoxy. So that means the 1 goes here because B comes first alphabetically. And the 3 goes here because C comes next alphabetically. Putting this all together, we have 1 bromo, 3 chloro, 5 ethoxy, benzene. Occasionally we will have a situation where the benzene has a suffix-changing functional group. For example, this compound here can be named methylbenzene because it has a methyl group, or it can also be referred to as a toluene. This next one can be methoxybenzene because it has a methoxy group, or it can be called an anisole. Toluene and anisole are historically common names, but IUPAC has adopted them. You can also see an example of an isopropyl benzene, commonly referred to as a cumene, and a vinyl benzene, commonly referred to as styrene. But cumene and styrene are common names and are not IUPAC. When we use the name toluene or anisole, we have to adopt the same rules for naming these molecules as we do for other suffix-changing functional groups. That means that you would have to give priority to the suffix-changing functional group. Let's look at some examples of that. In our first example, we have a toluene. The toluene includes the methyl group, and because the toluene is a suffix-changing functional group, that means that the methyl group has to get the number 1. We then number to the right because the next substituent is at position 2. So this becomes a 2-ethyl 4-pentyl toluene. In our second toluene example, here's our parent chain. The carbon with the methyl group that's part of the toluene gets the number 1, and we number to the left to give the chlorine number 2. So this is referred to as 2-chloro toluene. It can also be called orthochlorotoluene or O-chlorotoluene. In our last toluene example, here's our parent chain. The 1 has to go right here because that's where the methyl group from the toluene is. And then we have 1, 2, 3 nitro groups at positions 2, 4, and 6. So this becomes 2,4,6 trinitrotoluene, which is commonly referred to as TNT. The bottom 2 examples have anisoles. So you can see our parent chain for the anisole right here. The 1 has to go with the carbon attached to the anisole. And in this case, we number counterclockwise because that's where the next substituent is. So we have a 3-nitro anisole. You can also call this meta-nitroanisole or M-nitroanisole. In our last example, here's the anisole here. Again, the anisole gets number 1, so that gives us 4-propoxy anisole. You could also call this para-propoxy anisole or p-propoxy anisole. Hopefully you've noticed that the toluene very specifically contains only a methyl group. An ethyl group doesn't count as a toluene. And an anisole very specifically contains a methoxy group. Other ethers would not count as an anisole.